Hello everyone, this is Vicky from NIPER. In this video, I will discuss some important points for chemistry. I'm sure that this video will help you to score some good marks from chemistry in your final GPAT exam. So now let's start. So the first is the calibration standard for infrared spectroscopy is carried out by using polystyrene. So polystyrene is used to calibrate the infrared spectroscopy instrument. Next is the sampling of solids in IR spectroscopy is done by using a solution called Nuzol's technique by using a solution Mulling's reagent, which is a mineral oil. So the solid sample preparation in IR spectroscopy is done by Mulling's reagent or Nuzol's technique. The flame photometry is applied only for the group 1A and group 2A elements of your periodic table. So the flame photometry is used to apply is applied for only group 1 and group 2A elements. So the order of SN1 reaction for carbocation stability is the tertiary carbocation is more stable than secondary, then primary, then methyl. So for SN1 follows the polar and protic solvents. And for SN2, also known as your Walden inversion, here the stability is methyl followed by primary, then secondary, then tertiary. Here it is a polar aprotic solvent. And the free radical stability is tertiary, then secondary, then primary, then methyl. So this is very important. These points are very important. So you should study the SN1, SN2, Markov-Vinov and anti-Markov rules of chemistry. Those are very important. And the biphenyl compounds shows heteroisomerism. So this again, it's a very repeated bit for NIPER. So the biphenyl compound shows heteroisomerism. And here the order of stability of conformation of cyclohexane. So for cyclohexane, the conformation stability order is chair, twisted boat, and then half chair. So this is the order of stability of cyclohexane conformation. This question was asked in NIPER 2024. So this is very important. And the order of stability of conformation of N-butane. This is for cyclohexane. For N-butane, it is a fully staggered, then skew staggered, then skew eclipsed, then total eclipsed. So this is the order for stability of conformation of N-butane. Here the basicity order of your heterocyclic compounds is your piperidine is more base than pyridine than pyrrole. So this is the basicity order of some heterocyclic compounds. And for Karl-Fischer titration, generally Karl-Fischer titration is used to measure the moisture content in your sample. So for that we have a Karl-Fischer titration, we have a Karl-Fischer reagent, and that reagent composed of iodine plus sulfur oxide plus any base that may be imidazole or pyridine plus some solvent. So this is the reagent, Karl-Fischer reagent composition, that is iodine plus sulfur dioxide plus base. And you should focus on all the limit tests which are given in your inorganic chemistry. Those limit tests are very important. So here the limit test for arsenic is performed by using a specific apparatus known as Gudget apparatus. So Gudget apparatus are used for limit test of arsenic. So focus on all the limit tests, that a limit test for iron, limit test for arsenic, limit test for sulfur, etc. So focus on all those, study all those things. The order of electronic transitions in UV. In UV, the electronic transitions order is sigma to sigma star, n to sigma star, then pi to pi star, and then n to pi star. And also study the different bands, that is K band, B band, R band, when the K band occurs, and their forbidden transitions also. Study these things. And also the bathochromic shift and hypsochromic shift. So study those shifts also. The bathochromic shift, also known as your red shift, that is a compound shifted to longer wavelength. So when the compound shifted from normal wavelength to the longer wavelength, it is called bathochromic shift. And if the compound shifts from normal wavelength to shorter wavelength, it is hypsochromic shift, also known as blue shift. So in generally when the conjugation occurs, then the compound shifted to longer wavelength, that is bathochromic shift. Also we'll discuss IR. In infrared spectroscopy, the degree of vibrational freedoms. Generally, electronic transitions occur in UV spectroscopy and vibrational transitions occur in IR, infrared spectroscopy. So, the number of vibration frequencies for IR can be calculated using a formula 3n minus 5 for linear compounds and 3n minus 6 for non-linear compounds, where n is equal to number of atoms. So again, this is also very important. And focus on some important regions of IR. That is, the fingerprint region of IR is nearly 1500 centimeter inverse to 400 centimeter inverse, and the functional group region of IR is around 4000 centimeters to 1500 centimeters. And also study the some regions of OH and some main important regions of functional groups, and also study the types of vibrations occurs in infrared spectroscopy. There are two types, mainly stretching and bending, where the stretching also classified as symmetric and asymmetric, where bending is also classified as in-plane bending and out-plane bending. Again, in in-plane we have a scissoring and rocking, and out-plane we have wagging and twinning. So study these things also, and also focus on all the sources and detectors of all the instruments that are mentioned in your PCI syllabus, mainly for the mass spectroscopy, mass spectrometry, IR, UV also, NMR also. So follow this, focus on the sources and detectors also. And we have turbidometry, which is used to uh, measurement of intensity of transmitted light. So your turbidometry helps to measure the intensity of your transmitted light at 180-degree angle. And for nephelometry, it helps to measure the intensity of scattered light. So just remember, turbidometry is used to measure the intensity of transmitted light, and nephelometry is used to measure the intensity of scattered light. So look at these things also. And this is very common and very basic, that is from chromatography. For normal phase, the stationary phase should be polar and mobile phase is non-polar. And for reverse phase chromatography, the stationary phase is non-polar and the mobile phase is polar. Again, this question was asked in NIPER 2024. And also look into the aromaticity, that is Huckel's rule, 4n plus 2. Just study aromaticity, like what, how to identify the compound is aromatic or anti-aromatic or non-aromatic. So study the aromaticity, and study the structural isomerism types, that is chain isomerism, position isomerism, functional, metamerism, tautomerism. Study all the isomerism, and study the Chan-Ingo rules also for detecting R and S configuration. That is also important. And study Woodward-Fisher rules. So this, every year one question is guaranteed from Woodward-Fisher rules. So these are some important points to be remembered in chemistry part. And also study some cycles and vitamins, amino acids, those things from biochemistry part, that may ask from, that also cover the chemistry part. And for medicinal chemistry, I'll discuss some important points of medicinal chemistry in my next video. So thank you. Subscribe to this channel and share with your friends. All the best.